All right, and we're back. So we're going to look at week 2, and perhaps this might be number 15 for you. It is for me. So people are struggling with this question, so I thought let's just take a look at it. So we've got a company that makes crayons. I wonder what company that is. They're trying to decide which 4 colors to include in a mini box of 4 crayons. The company can choose the 4 mini box colors from its collection of 70 colors. How many mini boxes are possible? Okay, so I put the combination and the permutation formula on here because we need to decide, is this a combination scenario or is this a permutation scenario? They say nothing at all about the order of the colors. So if order doesn't matter, we're going to choose, dun dun dun, you got it, the combination. So we're not going to do a permutation. So what we're looking for is, we've got 70 colors and we're going to choose 4. Okay, so our 70 becomes our N, the total number of items, and R is those 4 colors they're going to choose. All right, so we're going to follow the script. We're going to use this formula here. So in the bikini top, we're going to put 70 factorial. And in the bottom, we're going to put 4 factorial times 70 minus 4 factorial. That's our bikini bottom. Okay, whew. I really do not want to multiply 70 times 69 times 68. Luckily, I don't think we're going to have to. So up top, we have 70 factorial. So we have 4 factorial in the basement, and then 70 minus 4 would be 66 factorial. Okay, so hopefully you have figured out that you can sort of do a little cheating here. So I'll do 70, 69, 68, 67, 66. Okay, and then down the bottom, I have 66 times 65, right? And then we also have 4 times 3 times 2 times 1. All right, so thank God we can cancel out 66 and everything below that, right? So that's going to leave us with, up top, we're going to multiply 70 times 69 times 68 times 67. And that should come out to be what? 22,005,480. All right, in the bottom, we're going to do 4 times 3 times 2 times 1. That's going to be 24. All right, so Crayola, let's just say, this is the company. If they have 70 colors to choose from, and they're going to try to decide which 4 colors to include, they have a total of 916,895 possible combinations. That's a lot of choices. All right, let's go on to a restaurant. We've got Heather, and looks like she's having a party, and she checks out this restaurant that offers 15 appetizers. And I guess her deal is she gets to choose 13 for her party, and they're looking for how many groups of 13 appetizers are possible. Okay, again, order does not seem to matter. I don't think Heather cares about the order of her appetizers, so we're going to stay away from where order does matter with permutations, and we're going to choose combinations. So she has 15 total appetizers, and she's going to choose 13 for her party, and she wants to know how many groups of 13 appetizers are possible. So we know this is our N, and this is our R. So feel free to pause the video at any time and crank this out, and then come back and let's see if we match. Okay, so if we're back, hopefully you got 15 factorial up here, you got 13 factorial, and then 15 minus 13 factorial. That's going to simplify to 15 factorial over 13 factorial 2 factorial. All right, so if we were to write this out, let's choose blue here. we've got 15 times 14 times 13 times 12. And that's going to keep on going. Down the bottom, we have 2 times 1. That's that 2 factorial. And then we have 13 times 12, dot, dot, dot. So the fun part is you get to cancel out the 13 and below. So up top, we have 15 times 14. It's going to be 210. In the bikini bottom, we got, which is the denominator, 2 times 1. If we cut 210 in half, that's 105 possible combinations that Heather can choose for her appetizers for the 13 that she's going to choose for her party. All right, we'll see you in the next one.